This is the fifth in my series of lectures on statistics for nuclear medicine. I'm going to be talking about parametric tests for comparing means in this lecture, and this part 1 is an introduction to the lecture. Tests for comparing means are all parametric tests. That is, they require quantitative data. It doesn't matter whether that's on an interval or a ratio scale, as long as it's quantitative, that is, they are numbers. All these tests assume that data are approximately normally distributed. That doesn't have to be rigorous, they don't have to be a perfect normal distribution, as long as it's roughly normal. These are tests for comparing means that I'm talking about in this lecture. I'm not talking about comparing standard deviations at the moment. We'll deal with comparing standard deviations in a later lecture. The tests in this lecture fall into three groups. There are single sample tests for comparing a sample with a known population, two sample tests for comparing two samples, and tests for comparing more than two samples when we're comparing several samples. Single sample tests include the normal distribution test, which I'll talk about in part 2 of this lecture. That's used to compare a single measurement with a known population. The one sample Z test I'll talk about in part 3 of this lecture. That's used to compare a sample mean with a known population mean when the population standard deviation is known. That's very similar to the one sample T test, which I'll talk about in part 4 of this lecture. That's also used to compare a sample mean with a known population mean, but it's used when the population standard deviation is not known, compared with the Z test when the population standard deviation is known. All of those tests are not specifically programmed in Excel, but since they only require the calculation of mean and standard deviation, they're very easy to calculate with Excel or by hand if necessary. In part 5 of this lecture I'll be talking about testing for agreement, either agreement between a measurement and a known value, or agreement between two measurements, and these will be done using confidence intervals. Two sample tests include the paired t-test, which I'll talk about in part 6. This is used to examine the mean difference between two paired samples, and the two sample z-test I'll deal with in part 7, which is to test the difference between the means of two unpaired samples. And we use the two sample z-test when the population standard deviations are known, and we have the unpaired t-test to test the difference between the means of two unpaired samples when the population standard deviations are not known. So once again we have the t-test when the standard deviations are not known, and the z-test when the standard deviations are known. Those tests are all available in Excel using the data analysis tool. But if you want to use the data analysis tool, you have to first install the analysis tool pack. But once you've done that, all these tests are very easily calculated in Excel. I'll be dealing with more than two samples in part 8 of this lecture, when we'll talk about analysis of variance, known as ANOVA. We'll talk about multiple paired samples, multiple unpaired samples, and multiple paired samples with repeats. These tests are all available in Excel using the data analysis tool, as long as you've installed the analysis tool pack first. So that's the end of part 1, which is an introduction to this lecture.